Today we will do chapter 4 of science, class 10, carbon and its compound. As we know, carbon is an element which is non-metal and its symbol is C, capital C. Carbon is a versatile element present in earth crust in form of mineral 0.2%, 0.02% and atmosphere as CO2 which is C 0.03%. All living things, plants and animals are made of carbon based compound. Carbon always form covalent bond because the atomic number of carbon is 6, electronic configuration K and L. K contain 2 atoms, electrons and contain 4 electrons. So in outermost shell there are 4 electrons. So it forms covalent bonds. How carbon attain noble gas configuration? Carbon is tetravalent. It does not form ionic bond by either losing 4 electron or by gaining 4 electron. It is difficult to hold 4 extra electrons and would require large amount of energy to remove 4 electrons. So carbon can form the bond by sharing its electron with the electron of other carbon atom or with the other element and attain a noble gas configuration. Atoms of other elements like hydrogen, oxygen and nitrogen and chlorine also form bond by sharing of electrons. The bond formed by sharing of electron between same or different atom is covalent bond. We will see here if we take 2H2, then H contain 1 electron in their outermost shell and these H2 also have 1 valence electron. These 1 electrons share together and they form they form a bond. There is one shared pair of electron in it. So H and H have one shared pair of electrons, so it contains a single bond between the hydrogen atom. For oxygen, O has 6 valence electron and O has 6 electron in their outermost shell and this O also have 6 electron in their outermost shell. These two electrons pair share together and they shared pair of electron. There are two shared pair of electrons, so they form double bond. In nitrogen have 5 electrons in their outermost shell, so these 3 electron share their electrons and they share the 3 pair of electrons in nitrogen, so triple bond is formed here double bond, here single bond. Molecule of water has single covalent bond between one oxygen and 2 hydrogen atom. One hydrogen here and 6 oxygen electrons here and 1 hydrogen electron here. They combine and make HO and H bond. Single bond here, single bond here. So there are 2 single bond in water. Physical properties of covalent compound. Covalent compound have low melting and boiling point as they have weak intermolecular force. They are generally poor conductor of electricity as electrons are shared between atoms and no charged particles are formed. Versatile nature of carbon. Two characteristic property of carbon element which led to formation of large number of compounds are: number 1, catenation, means carbon can link with carbon atom by mean of covalent bond to form long chain, branch chain, close ring. Compound carbon atom may be linked by single, double or triple bond. So it possesses a property which is known as catenation. Number 2, tetravalency. Carbon has 4 valence electron, so carbon can bond with 4 carbon atom, monovalent atom, oxygen, nitrogen and sulfur. Saturated and unsaturated carbon atoms compounds. Hydrocarbons are saturated and unsaturated. Single bond between carbon atom are saturated. Double or triple bond between carbon atoms are unsaturated. Examples: C single bond C, and here C double bond C or C triple bond C. They are they are alkanes. They are alkenes or alkynes. Double bond naming is alkene. Triple bond naming is alkynes. Their general formula is CnH2n plus 2. Their general formula is TnH2n, and their general formula is CnH2n minus 2. Here 2 electrons are positive, 2 electrons are added, and here 2 electrons are subtracted, and here only 2n is found. Now we will study electron structure of saturated hydrocarbon. Take 2 carbon, and with 2 carbon there are 6 number of lone pairs, so 6 hydrogen atom can combine here and they share their electrons. As you can see here, carbon and hydrogen, they combine and make their electrons full, and they also share their electrons. So C make single bond with H and all the H atoms. The name and the molecular formula and saturated formula of saturated hydrocarbon are as given there. For methane, its formula is CH4, and the structural formula is CH4R. 4 are arranged in this manner: C here and HR here. For ethane, the molecular formula is C2H6. Here 2 carbon, so hydrogen are placed there. For propane, it is C3H8, and their structural formula is this. For butane, it is C4H10, and their structural formula is this. For pentane, the molecular formula is this and the structural formula is this. So if we have 1 carbon, we can call this meth, 2 carbon eth, 3 carbon prop, 4 carbon bute, 5 carbon pent, and ane is ane means there is single bond in the in these hydrocarbons. So for single bond we write ane, and for number of carbon we write meth, eth, prop, bute or pent. So ane signifies that they have single bond in these compounds. Now electron dot structure of unsaturated carbons. Here we take 2 carbon and 4 hydrogen, they combine together and share electrons. So the structure is like this. Here C is making double bond in between, and here C is making triple bond in between, because 3 pair of electrons are shared here and 2 pairs are shared here. Now name of hydrocarbon for alkenes. Ethene means it contains 2 carbon. Propene means it contains 3 carbon. Butane means it contains 4 carbon, and their structural formula is it contains double bond in between here and here, and HR placed here and here. So C4, the arrangement of 4 is like this. Next one, carbon compound on the basis of structure, straight or branch chain. If we take 3 carbon, and H8, we can arrange it like this in single bond. Four branched structure, we can arrange C5 as like this or this. Both are possible. For isomerism of C5 and H12, we can write uh, the structural formula as like this or this. This is the straight chain structure, this is branch chain structure. Cyclic are those structure which are closed, which are closed and making bond, single bond or double bond or triple bond. For saturated cyclic, the structural formula is like this. For unsaturated double bonded, the formula is like this. And we can make the structure like this also. Here H are placed as single bonded. Here there is a double bond between carbon atoms and single bond with carbon and hydrogen. Now move on to functional group. In hydrogen chain, one or more hydrogen atom is replaced by other atom in accordance with their valencies. These are heteroatoms. These heteroatoms or group of atoms which make carbon compound reactive and decide its properties known as functional group. For example, heteroatoms, chlorine or bromine. Halo, it is called halo group, and we can for chlorine we can write chloro. For bromine we can write bromo, and formula is ClBr. For heteroatom is oxygen. Alcohol, for alcohol the formula is OH. For aldehyde group the formula is like this. For ketone the formula is like this. For carboxylic acid formula is like this. Single they are for single bond alkene groups we can write the formula like this. For alkyne group the formula is like this. You have to learn all these formulas. Homologous series, it is series of compound in which the same functional group substitute for the hydrogen in carbon chain. Alcohol, CH3OH. If OH is written at the end, then this is called alcohol group. Here and here OH is written, so we can say that this is the alcohol group. They have same general formula. Any two homologous differs by CH2 group. There is a difference of CH2 group in each compounds, and difference in molecular mass is 14 mu. They have same chemical properties but show gradual change in physical properties. Nomenclature of carbon compound. Identify the number of carbon atom in the compound first of all, and then functional group is indicated by suffix or prefix. Halogen. For halogen we can use prefix and suffix like prefix chloro, bromo, iodo, etc. Example like this. For alcohol suffix is ol and the formula is this. For aldehyde suffix is al and formula is this. For ketone suffix is 1 and formula is this. Carboxylic acid suffix is oic acid and the formula is this. For alkene suffix is this and the formula is this. This is not the formula, they are all the examples. Here if Cl is at the end we can call it chloro. If there is bromine then we can call it bromo, or if there is iodine then we can call it iodo. Now, what is alkyne? Alkyne. Alkyne. For alkyne, the suffix is yne, and the example is this: propyne. Chemical formula of carbon compounds. Number 1, combustion. Example: CH4 when react with O2O2 combustion, it gives carbon dioxide gas, water, heat and light. This is very important reaction. Number 2, carbon and its compound are used as fuel because they burn in air and release lot of heat energy. Saturated hydrocarbon generally burn in air with blue or non-sooty flame. Unsaturated hydrocarbon burn in air with a yellow sooty flame because percentage of carbon is higher than saturated hydrocarbon, which does not get completely oxidized in air. Number 2, oxidation. Alcohol can be converted to carboxylic acid in presence of oxidizing agent alkaline KMnO4, potassium permanganate or acidic potassium dichromate. The reaction is ethanol react with alkaline KMnO4 or acidic K2Cr2O7. It gives ethanoic acid. C. Addition reaction. If we take unsaturated hydrocarbon and add hydrogen in presence of catalyst, palladium or nickel, vegetable oil are converted into vegetable ghee using this process, and it is also called the hydrogenation of vegetable oil. Substitution reaction. When CH4 combined with chlorine in presence of sunlight, it gives CH3Cl plus HCl. Important carbon compounds, ethanol and ethanoic acid, their physical properties. Physical properties of ethanol: it is colorless, it has pleasant smell and burning taste. It is soluble in water, it is volatile liquid with low boiling point of 351 Kelvin, and it is neutral compound. Chemical properties: reaction with sodium. When sodium react with CH3CH2OH, it gives sodium ethoxide and hydrogen gas is released. This reaction is used as a test for ethanol by evolution of H2 gas, which is burned and making popping sound. Number 2, dehydration. CH3CH2OH with hot concentrated H2SO4, it gives CH2 double bond CH2 plus H2O. Physical properties of ethanoic acid: it is colorless liquid having sour taste and have smell of vinegar. Its boiling point is 391 Kelvin. When pure CH3COH is freezes, it forms colorless ice like solid, as it is called glacial acetic acid. Chemical properties: esterification process, very important. Ethanoic acid, when combined with ethanol with acid, it gives ester. Sweet smelling ester is formed here. And ester, when combined with NaOH, it gives CH3COONA and CH3CH2OH. This process is known as saponification, as a soap is prepared by this process. This is the preparation of soap. Reaction with base: when NaOH reacts with CH3COOH, it gives sodium acetate plus water. Number 3, reaction with carbonates and hydrogen carbonates. When 2 CH3COH combined with NaCO3, it gives CH3CONA 2 molecules, and water and carbon dioxide gas is released. When CH3COH combined with NaHCO3, it gives sodium acetate, water and CO2 is produced here. Soaps and detergent. Soap is sodium or potassium salt of long chain carboxylic acid. Their formula is: example, C17H55COO Na plus. Sodium soaps are effective only in soft water. Detergent are ammonia or sulfonate salt of long chain of carboxylic acid. Detergent are effective in both hard and soft water. So detergent are better than soaps. Soap molecule has soap is Soap molecule has ionic part and long hydrocarbon chain part. The ionic part is known as hydrophilic and the long hydrocarbon chain part is called hydrophobic. This end is hydrophilic and this is hydrophobic. Cleansing action of soap. Most dirt is oily in nature and hydrophobic end, which is this end, attached itself with dirt and ionic end is surrounded with molecules of water. These result in the formation of radial structure called the micelles. This structure. Soap micelles help to dissolve dirt and grease in water and clothes get clean. Suppose this is the dirt and this is the soap. So the hydrophobic part stick with the oil droplet and uh, it remove the dirt from the clothes and cloth get cleaned. The magnesium and calcium salt present in hard water react with soap molecule to form insoluble product called the scum. This scum create difficulty in cleansing action. By use of detergent, insoluble scum is not formed with hard water and clothes get clean effectively. As we can see that when we wash clothes in hard water, a white curd like structure is formed, and then that structure which is like the curd is known as scum. So we cannot wash water we cannot wash clothes in that water because cleansing action is not properly done in hard water. Here, this is the end of the chapter. Thank you so much. Please share, comment, or subscribe.